In the previous class we covered virtual memory concept and page replacement algorithm, right? And today we are going to cover disk management part. So what is all about disk management and what are the scheduling algorithms we have? So before going to the disk management, simply what OS provides under the disk management function, it's 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 uh, it simply manages its disk head movement, right? So that the latency of accessing any record of the disk should be minimum, right? So this topic comes under the IO management part, and disk is a IO device, right? So before understanding the disk management, first we have to understand how our secondary drive hard disk looks like, right? So as you all know, hard disk looks like something like that, like that. This is the structure of disk, and this will be your head, right? Reader writer head, right? And there are some plates or CD like structure which we used to know as platters. It is called platters, right? And this one is known as cylinder, right? This is the cylinder part. Cylinder. See, if we combine those cylinders by dotted line, you will know that why we are calling them cylinders, right? And these are the tracks, right? If we simply draw it and vertical cut, then you will better understand, right? This will be your head arm. These are the cylinder points. These are platers, and these are tracks, right? And this is reader writer head, right? The arm is having reader writer head, and the head move between cylinders, right? So these are the cylinders, and that's how it is moved. So these are the tracks, or we can say cylinders. This complete, if we complete it, it is looks like a cylinder. That's why it is called cylinder. So our disk looks like that, right? So to understand different terms we are going to use in the topic, we need to first understand what we are talking about, right? So a single platter will look like this, this, right? And this complete this complete this complete round, this complete circle is identified as track or cylinder. In the second term we can say it is cylinder, right? And the different partition area of that particular cylinders are commonly called as sectors. So this is called sectors, right? And these are and complete and this complete area is called as a cluster. So mainly we are dealing with the term track or cylinder and sectors, right? So these are the major terms we will use in discussion part under disk management. So in the disk management, what OS will do, OS will simply schedule all the disk requests coming from the processes into a manner so that the latency to read write latency of accessing those particular records or disk request will be should be minimum, right? So that means what OS will do in disk management, it's simply disk scheduling. What we are going to do, we are going to simply schedule IO request coming coming from processes on disk access, on disk or disk access, you can write it like that. So simply to understand better, we can draw a diagram. This is our processor CPU. Multiple disk requests are coming, disk access request. These are disk access request coming from processes, different processes. Let's say P1, P2, P3, P4. And at a time CPU will provide only one process for CPU will provide a chance for only one process, so rest of the process will be scheduled under disk queue, right? So what it will do, it will choose P1 and provide it disk, right? In the meanwhile, all the request in the system, disk request in the system will be scheduled to our disk queue, like waiting queue. IO devices has its own queues. OS manage different IO queues, as we understood in the process management part. So there will be disk queue, and rest of the processes till P1 is accessing disk, rest of the processes P2, P3, P4 will be queued in disk queue via operating system function name as disk scheduler, disk scheduler, which is responsible for scheduling requests into disk queues, right? So this is all about the disk scheduling part. So before uh, before going to the disk scheduling, we need to first understand what all are the disk scheduling criterias we have. So we have some criterias for disk scheduling, which are as follows, right? First criteria is seek time. Now you will get to know why I draw these diagrams before, because it will come into the definition, right? So seek time should be minimum. I am writing minimum, that means it should be minimum. So seek time is the time taken by disk head to move from one cylinder one cylinder or one track to another to another See, head movement is only applicable only for forward and backward, forward direction or backward direction. It can't rotate. It can move only into the forward direction or reverse direction, either this way or this way. It will go forward and backward in the direction of this cylinders, right? So time taken by the disk head to move from one cylinder to another, that means the time taken by head from moving from here to here is considered as a seek time, right? See here, from here to here or here to here, this is considered as seek time, and seek time depends on it depends on a sorry, I should write some other variable. 1, seek time depends on first seek length. For example, if head moves from 13 to cylinder number 34, that means seek length will be 21. 34 minus 13, right? And second, it depends on time required to move from cylinder cylinder 1 to 2, let's say. That means this is also reference as acceleration factor. So seek time depends on seek length and acceleration factor of a head, right? So mathematically, seek time for n equals to 0 if n is 0. And what is n? N is this one, seek length, right? Logically it is correct. If head is not moving, that means seek time will be 0, right? And seek time n will be a plus b n if n is greater than 0. And what is a and b? Here a is mechanical settling time, and b is acceleration factor acceleration factor factor. So if n is greater than 0, then seek time will be a plus b n, and where a is mechanical settling factor, that means because head is a mechanical device, so it needs to settle before going to forward and backward. So that's why mechanical settling time will be added and acceleration factor will be added. That means number of cylinder it traveled and the speed of travel, right? That's why that is given. Second second criteria second criteria will be rotational rotational latency. What it is? It is simply time required for moving our platter to the correct position, right? Because head cannot move round in the round fashion, circular way, right? So we need to move platter. So it is time taken by addressed sector of track or cylinder to rotate into a position such that read write head is accessible to it. Right, what we meant for this line, it's simply because head can move only from here to here, it cannot move circularly, right? It is not possible, so circular motion is provided by platter only. So if head is here, then particular record has to be made available at this point, at this point. So this circular rotation latency, total time taken by that particular track to come under the head, is called as rotational latency. How much time we need to rotate that particular platter to the head position, right? That's what the rotational latency means, right? Third criteria we have transfer time. Transfer time, which is simply time taken to transfer data from disk to application, requesting application. It is the total transfer time. It depends on depends on one, rotational latency which defined earlier, and second, number of bytes trans to be transferred to be transferred to be transferred because the time taken by rotational latency plus total number of bytes we have to transfer, because there is a limitation on the transfer rate, right? Disk read write head has a limitation on reading writing speed, so reading speed matters a lot. So total transfer time will be time taken by to the time taken to transfer it data from disk to application. So these two factors are considered under the transfer time. Fourth one will be disk access time. These are now these are hybrid criterias. So total disk access time will be known as time to perform any operation on disk, either it is writing operation or reading operation. So it will be equals to summation of seek time, rotation time, rotational latency, and transfer time. The summation of all these three times will be known as disk access time, right? And next, fifth one, we have disk bandwidth. Disk bandwidth. Disk bandwidth will be equals to total number of bytes transferred upon total time. And total time, what we means by total time, it's from first request to completion of last transfer of data. From request to completion of transfer of data, total time taken by under the category from first request to completion of last transfer of data. So total number of bytes divided by total time, by this formula we will get total disk bandwidth, right? And sixth one, we will have throughput. Throughput will be equals to total number of disk requests, total number of disk requests served, upon total unit time, or we can say unit time. How many total disk request has been served in per unit time, that is called throughput of that particular disk, right? It should be maximum. And seventh, we have response time. It should be minimum, right? It is average time spent by a request in waiting. What it means by in waiting? From request to completion, right? So by using this diagram, let me draw a diagram, then it will be easy for you to understand what I am talking about, these all criterias. So disk queuing delays suffered due to disk queue, right? The disk request time spent by a request in the disk queue, right? It is named as disk queuing delay. Next, seek time, we understood it, seek time. Next will be rotational latency, and last will be data transfer time. So these are three commonly known as disk access time, right, as we discussed earlier. And these all four commonly known as disk response time. Means from start of that request, from start of that request to the completion of that request is known as disk response time. After how much time the disk responded, right? So it is the summation of the queuing delay which occurred here. This is queuing delay, putting process into the queue, and after and taking back that particular process for the disk, right? Scheduling that particular process to the disk, right? So that is queuing delay, right? So queuing delay will be added to all the times all the times of disk latencies, like seek time, rotational latency, data transfer time, will be commonly known as disk response time. And apart from disk delay, if we will not, we are not considering disk queuing delay, then seek time plus rotational time plus data transfer time will be considered as disk access time, right guys? So we have to minimize delays in the disk accesses, right? So response time should be minimum, throughput should be max, disk bandwidth should be high enough, it should be high, disk access time should be minimum, because if the delays are minimum, definitely our access time will be shorter. So shorter the access time, the more the request we can serve in the system, right? Transfer time should be minimum, rotational latency, it will be constant, right? It will be constant because every manufacturer has its own latency. So the design, if it is decided by the designing of that particular disk, so it will be constant. And seek time should be minimum, right? So these all are the criteria according on which we these are the all the criteria, scheduling criteria on which we we check or we verify our scheduling algorithm that this that this particular algorithm is best or this particular algorithm is worst. Now come to the our main discussion part, which is disk scheduling algorithm. Now we are going to understand which are the disk scheduling algorithms we have, right? So before going to the detail of these, first understand, remember one thing, disk head can move only in this direction, either forward or backward. It cannot rotate itself because it is fixed in the hardware part, right? And only this platter will rotate, right? So remember these 2 points. Head can move only horizontally, okay, and our platter is able to move on in the direction of rotational direction, right? So these major 2 points you have to remember before solving these scheduling algorithms, right? So in the scheduling algorithms part, what these do, it simply schedule our disk request coming from different processes for accessing that particular disk, so that our disk access time will be should be shorter and all the delays should be minimized, right? So for that we have different algorithm, basic algorithm. We are understanding these algorithm. These are basic fundamental algorithms which generally a designer will use or can use, or it can use some other algorithm also, but these are the fundamental way we can schedule disk request, right? So first is FCFS, then we'll understand SSTF, then we will understand scan, then we will understand look, right? These are the major category, and under the scan category we have normal scan, then C scan, then F scan, and N step scan. So there will be 1 2 3 4 4 scheduling different scan algorithms we have, and in this look type scheduling, this scheduling we have basic look, and second we have C look, right? So all the scheduling algorithm have different procedures to follow, right? So let us understand by example one by one, because without example you will not understand it. Now let's go for FCFS, first come first serve, right? Let me write it: first come first serve. As the name suggests, request coming in a specific order will be served on that particular order. Whichever the request come first will be served first. So let us say, let us take an example. We have disk request for cylinders, for following cylinders in this order. We have first request is cylinder number 54, then second request is for cylinder number. These are cylinder numbers. Next request for 73, next for 128, next for 15, next for 14, next for 110, next for 34, next for 45, like that. These are the disk request or disk queue given, right? And current position of head is cylinder number 23. That means currently the head is at the cylinder number 23. Now let us solve it. So for solving, we will draw a diagram according to this. Let us say these are the cylinders numbering areas. This is 0, cylinder number 0. This is cylinder number 15. This is cylinder number 23. This is cylinder number 34. This is cylinder number 44, 45. See, I am drawing only those cylinders which are in the request. Cylinder number 54, cylinder number 73, cylinder number 97, cylinder number 110, and cylinder number 110 के बाद 128. I am not making last cylinder, assuming that 128 is the last cylinder we have in the disk, and total number of cylinder will be 128, right? So what the question is given to you is, currently head is, now let me change color so that it will looks nice to you. Currently head position is 23. So currently head is here, right? Currently head is here, and according to FCFS, every request is served according to the arrival time, right? So first request we have after 23, after 23, first request we have for 54. See, first request in the disk queue we have 54. So we need to move that particular head to that particular cylinder number. So that means our first move will be this one, 23 to 54. Now head is here, right? Head is at 54. Now after 54, head will move to 97. 97. Okay, and after 97, head must come to 73. See, after 73, it should come to 128. After 128, it should come to 15. 15, 15, 15, 15, this one. So after 128, cylinder number 128, it head will move to 15, right? And after 15, it will go for 44, and after 44, it will go for 110, 110, and after 110, it will go for 34, 34, and after 34, it will go for, oh sorry, it will go for, after 34, it will go for 45, 45. So for completing all the request, our head will move according to this. First head will move from 23 to 54 because first request is for 54, and after 54 second request we have for 97. So our head will move from 54 to 97, like, right? And after 97 next request is for 73, and like that we will draw all the moves. Why we are drawing them? Because then it will easy to calculate total head movement of this disk, right? So calculating total head movement, we will draw a table where we will record all the individual head movements, and then we'll take total of those, because total number of head movement will be considered as criteria for understanding that this particular scheduling algorithm is good one or best one or worst one, right? So first is IO request for cylinder, for which cylinder the request came. We will write it here, head, then we will calculate head movement, and total head movement, total head movement. Okay, so initially we know that head is at 23. Okay, and next request is for 54 according to given sequence. So we'll write 54 here, then head movement will be 54 minus 23 because head has to move from 23 to 54. So total difference between 23 to 54 will be 31, right? In the same way, for the second request, which is for 97, it will be 97 minus 54 because now head is at 54th position. So total movement will be 43. And next request is for 73. So 97 minus 73, that means total head movement will be 24. And next request is for 128. So 128 minus 73, total head moment will be 113. Next request is for 15. 128 minus 15, sorry, 113 is for this one. uh, this one is 55. This one is 55. Okay, next is request for 44. Then 44 currently head is at 15. 44 minus 15 equals to 32. Next movement is 44 to 110. So 110 minus 44, that will be equals to 66. And next request is for 34. So 110 minus 34 will be equals to 76. And last request is for 45, which will be equals to 45. Control Z. Let me write bigger number first. 45 minus 34 equals to 11. So total head moment for this sequence of request head moment according to FCFS will be 451. So this is how we solve these type of question, and according to FCFS, whichever the request come first will be served first. So it will be it will give the best result if your sequence of access this request is sorted one, right? And if it is not sorted one, then it may or may not give good result. Maybe if it is not sorted properly sorted, that means you will get the worst result for FCFS. Okay guys, so this is our disk scheduling criteria, and under this FCFS we covered FCFS. I think you understood it, and thanks. This is for That's all for the day guys. Thanks.